Hi there, my name is Olivia, and today we're going to be going through an ME 2410 or statics problem. The problem you see here is a space truss problem, which means you will be analyzing a three-dimensional structure whose forces are only applied at nodes or joints. This is my favorite kind of statics problem, and I'm so excited to share with you how to do it, so let's get started. The problem here is asking us to determine the force in each member of the space truss and state if the members are in compression or tension. It is also important to note that the truss is supported by ball and sock joints at A, B, C, and D. Before we begin solving, I want to go over a few things. We are going to be putting the coordinates of each of the joints. So that's going to be in the notation X, Y, and Z. However, when we move into the force vectors, these coordinates are going to turn into I, J, and K. We are also going to be working with unit vectors, which would be 0.2 minus 0.1. For our case, I'm just going to put arbitrary W, so W2 minus W1, since we've already used X. Now let's begin by labeling all of the coordinates, starting with A. A has the coordinates of 0, minus 2, 0. B has coordinates 0, positive 2, 0. C has coordinates 0, 2, 4. D, 0, minus 2, positive 4. E, 4, 0, 0. And finally G, 4, 0, 4. Now let's focus in specifically at point G. So at G, we're going to make another small diagram representing exactly what's happening only at that point. We have 6 kilonewtons, 4 kilonewtons, the force of T, G, D, the force at T, G, C, and finally the force of T, G, E. So now we can analyze all of the forces acting on G. We're going to start by the initial force, which is going to be F of G, with this notation, which if you're taking the statics class at Wayne State, is most likely to use this kind of notation, which I'm going to be using here today, is equal to the force vector of 0, minus 4, minus 6. Which we can see that the 6 kilonewtons is pointing downwards and the 4 kilonewtons is pointing to the left, both indicating negative direction. And this also has the units of kilonewtons. Next, we're going to focus on TGD. So TGD equals, again, TGD, UV. UV is the unit vector, which simply denotes direction, which is important for this kind of problem because at the end when we determine if the members are in compression or tension, we're going to need to know the direction in which the force is being applied. So that's why we're going to use the unit vector. However, for this part, when we put in the vector, this is when that W2 minus W1 is going to come into play. So I'm going to actually write up in this yellow box how we're going to do that. So essentially, D is going to be signified as W2 and G, W1. So we know that we're going to put the X's together, the Y's together, and the Z's together. So we can do 0 minus 4, which would equal minus 4, minus 2 minus 0, which is going to be minus 2, and 4 minus 4, which equals 0. Here is what our force vector is going to contain. So I'm going to put over here minus 4, minus 2, 0 kilonewtons. So now we're going to expand on the unit vector. In this same yellow box over here, what I'm going to do is show you how to solve for the unit vector. Essentially, what you're going to do is you're going to take the square root of x squared plus y squared plus z squared. Or in our case, that's going to be I, J, and K. So let's plug in our numbers. Minus 4 squared plus minus 2 squared plus 0 squared. all underneath the square root, which is that's going to equal 4.472. So that's what's going to be going in our denominator. So essentially it's going to be u over the absolute value of u. So our u is going to be minus 4 over the unit vector of 4.472, and that equals, we'll go back over here, TGD negative 0.894. Now we'll do minus 2 over 4.472, which is going to equal negative 0.447, and then finally just 0 kilonewtons. This is actually going to be our second equation, and we'll go back to the f of g, which would be our first equation. Now we are going to move on to TGC. So, just like the last two problems, TGC with the same notation is going to equal TGC UV, again the unit vector, but in this case, we'll jump back over here, we're going to have 0, minus 4, 2, minus 0, and 4, minus 4. As you can see, we'll have minus 4, 2, 0 kilonewtons. Again, we'll solve for the unit vector. Minus 4 squared plus 2 squared plus 0 squared, which equals the same thing, so 4.472. Again, we'll solve for the following values. Which will then equal TGC 0.894, now positive 0.447, and 0 kilonewtons. And this will be our third equation. Now we're going to move on to TGE. And this one's a little different. Because these 2 points are directly vertical from each other, we're going to have TGE, TGE again, but this time the unit vector is going to be symbolized as 0, 0, minus 1 kilonewtons. And there's no need to do the unit vector because you'll get the same thing. And that is going to be our fourth equation. So now we can start making our matrix. The matrix is something that I would personally solve in a calculator, however you can do it by hand. But using the calculator is much quicker and much more efficient. But we'll set it up on paper so you understand how to input it. We're going to start by collecting all of our i's. However, f of g is going to be a little different because that's what we're going to set it equal to. So we'll grab this I, and this I. And then this is going to be j, J, and J, and finally this is going to be K, K, and then finally this negative 1 is also going to be K. So let's start by setting up our matrix. We're going to put in the first row all of the i's. Minus 0.894, then again negative 0.894, and finally 0. Then we'll have our j row, which will be minus 0.447, positive 0.447, and 0. Then finally, we'll have 0, 0, minus 1. You can look at this from two ways. We can see that we have I, J, K here, but we can also have T, G, D here, T, G, C here, and T, G, E here. So the next column we are going to have is exactly that. We're going to put that T, G, D is here, TGC is here and TGE is here. And what we're going to do is we're going to set that equal to f of g. So 0 minus 4 minus 6. Before we go into solving the matrix, what I want to do is explain how you would input that into your calculator. So the first thing you're going to want to do is determine what kind of calculator you have. I personally have a TI-84. So what I'm going to do, my first step is going to click second and then x to the negative 1, which is going to take me into the matrix option. The second step is to, if you don't already have matrices inputted, you're going to want to create one. So if you go to the left where it says edit, you'll be able to create your matrix. For this one, we're going to be using a 3 by 4. If you click edit and 3 by 4, it opens up the matrix for you to input all of your numbers. If you put them in exactly how you had them listed on the previous page, you'll be all set. The third step is to actually solve. So again, you'll quit the previous matrix. It'll take you back to your regular home page. Go back to second matrix again, or in this case, second to the x to the 1, and then go right 1, which will take you to the math page. If you go all the way to where it says B, RREF, parentheses, this is the program that you want to use for solving the matrix. So select RREF and then go back to second matrix again and click whatever your 3 by 4 matrix is, which in my case is going to be A. So I'm going to do this and then click solve or enter. The contents of your matrix should consist of 1s and 0s except for the last column. If you go all the way to the last column, that's where your answer is going to be. Jumping back over to this page, I have inputted everything into my matrix, did my RREF, and I got the final answers of, so T, G, D is going to equal minus 4.474 kilonewtons. I have TGC equal positive 4.474 kilonewtons. And finally, TGE equals 6.00 kilonewtons, which that is going to translate to our compression and tensions. So TGD is going to be 4.474 kilonewtons in compression because it's negative. TGC is going to be 4.474 in tension because it's in positive direction. And finally, TGE 6.00 is also going to be in tension. You might want to put kilonewtons at the end of these for units, but this is going to be your first 3 answers. As you can see, we are back to the main picture. And in most statics classes, they're going to ask you to label directly on the member. So that's what we're going to do. We're going to start with G and D, and that's going to be 4, I'm going to change my color. We'll do 4.474 in compression, or C in parentheses. For GC, we're going to do 4.474 parentheses T for tension. And finally, GE is going to be 6.00 also, with parentheses T for tension. Now let's go back and we'll focus on point E. As you can see, I have already labeled the coordinates, but now we're going to be focusing on specifically E. Again, we're going to draw another little diagram representing point E. So if we have a force pointing downwards, which is going to be TGE. Lucky for us, we already solved it. We have TED, TEA, and finally TEB. We will start with TEG because we just solved it. So we know that TEG is going to equal, in the unit vector, it's going to be represented as 0, 0, minus 6. And that's just because for point E specifically, TEG is pointing downwards, therefore it's going to be minus 6, even though it is a tension force. And that's going to be in kilonewtons. Next, and this is also going to be our first equation for this section. Next, we're going to focus on TED. Again, remember that formation we want to be using. TED UV, again, we need to focus on that unit vector, and the points. So again, let's see. E is here and D is there, which means we can do 0, minus 4, minus 2, minus 0, and 4 minus 0, which would put us at minus 4, minus 2, positive 4. And if we solve for our unit vector again, so we are going to be solving as minus 4 squared plus minus 2 squared plus 4 squared. This simply equals 6. So we'll do minus 4 divided by 6, minus 2 divided by 6, and positive 4 divided by 6. This puts us at TED negative 0.666, then negative 0.333, and then positive 0.666 kilonewtons. And this is going to be our second equation. Next, we're going to move into TEA, which will equal, again, TEA, UV. However, this time, if we look back at this graph, we will do 0 minus 4, negative 2 minus 0, and 0 minus 0. So we'll have minus 4, minus 2, and 0 kilonewtons, which will then translate into square root of minus 4 squared plus negative 2 squared plus 0 squared. Again, this equals 4.472. We are going to do the same process. Negative 4 divided by 4.472, negative 2 divided by 4.472, and 0 divided by 4.472. This will equal TEA negative 0.894, negative 0.447, and 0 kilonewtons. This is equation number 3. Finally, TEB. And that's going to equal TEB unit vector. From the previous slide, we see that 0 minus 4, 2 minus 0, and 0 minus 0, which will put us at negative 4, positive 2, and 0 kilonewtons. Using what we just solved from above, we can determine that it's going to be TEB negative 0.894, positive 0.447, again 0 kilonewtons, with this being our fourth equation. And the reason why we skipped all the extra information is because we just previously solved it, and if you can use some deductive reasoning, you can determine that they're going to be the same numbers, except in the J direction, this TEB is going to be positive instead of negative. Now let's focus in on writing out that matrix again. We're going to do the same thing as last time, where this is going to be our I column, this is going to be our J column, and this is going to be our K column. And by column, I meant to say row. So we'll begin with our, again, I just want to make note that this is going to be what we're setting everything equal to, but this is I, and I. This is going to be J, J, and J. And again, this is going to be K, K here, and finally a K here. So now we can write everything out. We'll start with minus 0.666, and then we'll do negative 0.894, and finally another negative 0.894. Then we'll move into negative 0.333, a 0.447. This one's going to be negative, and this one is going to be positive. And then 0.666 here, a 0 here, and a 0 here. Then we'll label that this is going to be TED, TEA, and TEB, which is all going to equal TGE, which is 0, 0, minus 6. Going back to the matrix slide, we will start by doing second x to the negative 1, which will be matrix. Editing our 3 by 4 matrix by putting in the previous numbers. Then second matrix again, go over to the right one to math, go down to B, which is going to be REEF. Click on that and choose the matrix that you just inputted for and click enter. We will get final answers. I'm going to put them right here. The final answers are going to be that TED equals 8.996 kilonewtons. TEA equals negative 6.706 kilonewtons. And TEB equals negative 0.5031 kilonewtons. Based on the previous section we just did, we can determine that this is going to be tension, this one is going to be compression, and this one is also going to be compression. However, when you rewrite this, you wouldn't need to add compression and negative. You would just put the number as a positive and then compression, which we will see right here. Like we just said, TED, which is this diagonal right here, is going to be 8.996 T for tension. TEA is going to be 6.706 compression, because the compression automatically signifies that it is a negative number. And then TEB is 0.5031 compression as well. Thank you so much for watching this video, and good luck with statics.